Hi, this is Manoj Yadav and you are watching Mechanotherapy. So, today we are going to discuss some very important concepts of fluid mechanics. So, the first question which comes in our mind is what actually a fluid is. So, we can define a fluid as any substance which has the tendency to flow naturally. That is called a fluid. Now, what is fluid mechanics? So, fluid mechanics may be defined as the science in which we study about the behavior of fluids, whether they are at rest or in motion. Now, there are three aspects of fluid mechanics. First one is fluid statics, then fluid kinematics, and then fluid kinetics. In fluid statics, we study about the behavior of fluids which are at rest, or we study the various properties when the fluid is at rest. Second one is fluid kinematics. Fluid kinematics is the branch of science that deals with behavior of fluids in motion where forces causing the motion are not considered. So we just study about the displacement, velocity and acceleration of the fluid particles. Then we have fluid kinetics. In fluid kinetics, we study about the fluids in motion and the forces due to which they are in motion are also considered. So this is all about fluid mechanics. Now we will discuss about the various properties of fluid mechanics. When we talk about fluid mean to say liquid as well as gas. So properties of fluid mechanics. First one is mass density or simple density. So mass density of a fluid may be defined as the ratio of mass of fluid to the volume of fluid, or we can say mass per unit volume of a fluid is known as mass density. Now this mass density is denoted by rho. So rho is equal to m upon v. Since mass is denoted in kilogram and volume in meter cube, so the unit of mass density is kilogram per meter cube. Now this mass density remains constant for liquids and it varies with temperature for gases. As you know, the mass density of water is 1000 kilogram per meter cube. The mass density of mercury is 13,600 kilogram per meter cube. So it is fixed for the liquids. The second property is weight density. As the name implies, the ratio of weight of a fluid to the volume of a fluid is known as weight density. Since weight is represented in Newton and volume in meter cube, so its unit is Newton per meter cube. Now we can derive the relation between mass density and weight density. Weight density is small w equal to weight upon volume. Now weight can be written as mass into g, mg divided by volume. Now m upon v, it represents the mass density rho. So we can write weight density small w equal to mass density multiplied by gravitational acceleration g. W is equal to rho g. Then very important property is specific volume. Specific volume of a fluid may be defined as the ratio of volume of fluid to the mass of fluid. So we can say it is the reciprocal of mass density. A unit is meter cube per kg. It is denoted by small v. So small v is equal to volume capital V divided by mass small m. We can write it as 1 upon m upon v, and m upon v is rho. So we can write specific volume small v is equal to 1 upon rho, that is it is the reciprocal of mass density. Now next property is specific gravity. Specific gravity of fluid. It may be defined as the ratio of weight density of a fluid to the weight density of ideal fluid. Now as you know, weight density of fluid means gas as well as liquid. So when we write the formula for specific gravity for liquid, we write it as specific gravity for liquid SL equal to weight density of liquid divided by weight density of ideal liquid, which is water. Similarly for gases, specific gravity for gas is equal to specific gravity of given gas, weight density of given gas divided by weight density of ideal gas, which is air. Now since specific gravity is a ratio of same quantities, so it is unitless. We can see that specific gravity of water is 1000 divided by 1000, that is 1. Similarly, specific gravity of mercury is 13.6. So it indicates that in respect to the ideal liquid or ideal gas, how heavy is the fluid. Okay. So next very important property is viscosity or dynamic viscosity. Now as you know that fluid moves in form of layers. Each and every layer opposes the motion of another adjacent layer. So this property of fluid, which offers resistance to the movement of one layer of fluid over another adjacent layer of fluid, is called viscosity or simply dynamic viscosity. Now viscosity is also defined as the rate of the shear stress required to produce unit rate of shear strain. According to Newton's law of viscosity, the shear stress developed between layers of fluid is directly proportional to rate of shear strain or velocity gradient. So we can write mathematically as shear stress tau is directly proportional to rate of shear strain du over dy. Or we can say tau is equal to mu du over dy. So from this equation we can find out mu equal to tau upon du over dy, where mu is the viscosity or dynamic viscosity. Now from this equation we can see the unit of viscosity is Newton second per meter square, and another unit which is used in fluid mechanics is poise. The relation between Newton second per meter square and poise is 1 Newton second per meter square is equal to 1 by 10 poise, or we can say 10 poise equal to 1 Newton second per meter square. 10 poise equal to 1 Newton second per meter square, or 1 poise equal to 1 by 10 Newton second per meter square. Then we have one more property of fluid, which is kinematic viscosity. Kinematic viscosity may be defined as the ratio of dynamic viscosity of fluid to the mass density of fluid. So it is denoted by nu. Nu is equal to mu upon rho. Dynamic viscosity mu divided by rho density. So its unit is meter square per second or stoke. This 1 stoke is equal to 1 centimeter square per second. So guys, this is all about the various properties of fluids. Now in our next lecture we will discuss about various types of fluids. What are the various types of fluids, that we will discuss in our next lecture. I hope you must have liked the video. Thank you everyone.